Good day.
I'm Jericho Rocky B. Deloso.
I'm Joshua Jake de Brigoli. I'm Emmanuel A. Adame.
We're here to present to you our study about the three-way coconut shell sander. Introduction. Coconuts are grown on more than 10 million hectares in 92 countries around the world. Indonesia, Philippines, and India produce nearly 75% of the world's coconuts. The Philippines, being the second largest producer based on the data from the Food and Agriculture Organization Corporate Statistical Database in the years 2016 to 2018, averaging about 14.2 metric tons of coconuts. In Bohol, they use the shell for handicrafts, utensils, and food containers for the calamay, a sticky sweet delicacy that is very popular in the province, especially in Hagna. It is being sold inside a half smooth sanded coconut shells, locally known in the province as bagol, and is sealed shut with a red crepe paper called papel de hapon. The very first step in order to make use of this shell is to clean the rough surfaces and excess husk fibers by sanding it with the use of sandpaper, which is very time consuming because they do it manually by their hands. Statement of the problem. The sanding of coconut shells for calamari production takes a lot of time and effort when doing it manually. In order to address this problem, the researchers would like to propose a three-way coconut shell sander, also to design and fabricate, that will be used by the calamari workers in sanding the coconut shells for efficiently than the manual operation, because this machine will help lessen the time taken to clean the coconut shells in order to boost the production rate. This machine will be beneficial and useful for the locals and to the calamari workers in Bahagna Bohol to adequately cater the demands of their products. Objective. The construction of this machine aims to design and fabricate a three-way coconut shell sander to test the functionality of the machine in sanding the coconut shell and its performance in the aspects of production rate, to evaluate the functionality of the machine in the aspects of quality of the sanded coconut shells, is in using the machine. Scope and limitations. The study is governed by the following scope and limitations: to smoothen the rough surfaces of the coconut shell using three types of sanders: ball, disc, and belt. The materials used as sanders are available locally. The efficiency of the machine will be tested according to the numbers of coconut shell being sanded and not by the cost of the machine. Parts of the machine. Motor is an electrical machine that converts electrical energy into mechanical energy. It operates through interaction between the motor's magnetic and winding currents, which generates a rotating force. Electric motors can be powered by direct current or alternating current. Bearing is a device that consists of smooth metal balls or rollers and smooth inner and outer surfaces known as races. The metal balls or rollers are used to provide a low friction means of motion and act as the load carrier of the device, allowing it to rotate freely. Shaft is a rotating machine element, usually circular in cross section, which is used to transmit power from one part to another, or from a machine which produces power to a machine which absorbs power. Belt is a loop of flexible material used to link two or more rotating shafts mechanically, most often parallel. Belts may be used as source of motion to transmit power efficiently or to track relative movement. Sander is a portable power tool used for smoothing, polishing, or cleaning a surface of a wood, plastic, or metal by abrasion with sandpaper. Sanders have a means to attach the sandpaper and a mechanism to move it rapidly contained within a housing, which means to handhold or to fix it to a workbench.
Equation: power P equals 2 pi T and bearing Fe equals NSF Fx. Shaft: tau equals TR over J. Belt: L equals 2C plus 1.57 D1 plus D2 plus D1 plus D2 squared over 4C. Columns: Euler's formula: Fc equals pi squared EE over LE over K squared for LA over K greater than 120. GB Johnson: FC equals NF equals SYA 1 minus SYLA over K squared over pi squared E for 30 LA over K less than 120. Methodology: the three-way coconut shell sander is designed to help workers create a faster, easier, and better quality of sanded coconut shell. Thus, this can be essential machine to the workers of the calamari. The machine is composed of the following major parts: sanders, frame, shaft, bearing, belt, and pulley and motor. This is the process flow in designing and testing of the machine. The conceptual designing of the machine: the ball sander, shaft, belt sander, disc sander, B-belt, motor, and the frame. The selection materials: the materials used in motor is electric in frame, angle bar in bevel leader in pillow block, cast iron in shop, ASI C10 45 cauldron in pulley, cast iron disc sander, backlot 36 grit in belt sander, backlot 36 grit and ball sander, backlot 36 grit. In procedure in assembling the machine, cut the angle bars based on the design dimension. Assemble the frame of the machine using the cut angle bars. Mount the AC motor to the frame. Connect the motor pulley to the shaft pulley with the belt. Mount the sander to their design places. And last, assemble the working table of the disc and a belt sander. This is the fabricated machine. The main objective of this study is design the fabricated manually assisted sanding machine that can aid in the sanding process of the coconut shell used as calamine containers. In procedure in testing the machine, gather the coconut shells intended for the sanding operation. Measure the thickness of the coconut shell before sanding. Sand the coconut shell on the machine. Monitor the record at time it takes to completely sand the coconut shell during sanding operation. Measure the thickness of the product after sanding and the last plot and analyze the result.
Evaluating. The researchers used a descriptive survey method with the use of questionnaire to be able to determine the quality of the sanded coconut shells and the ease of using the three-way coconut shell sander. The data were gathered from the 10 calamine workers in Hagna, Bohol. Before answering the questionnaires, the respondents are oriented on how to operate the machine and that they will be able to see its output. Testing and results. After the researchers designed and fabricated the machine, the researchers tested its performance and the functionality in terms of production rate. Below are the data of the test conducted together with its analysis and interpretations. Table 4.1. This table shows the result from the 4 trial testing of the three-way coconut shell sander. Table 4.2. This table shows the results of sanding coconut shell manually. Table 4.3. This table shows the comparison on the average sanding time between the machine and manual way of sanding coconut shells. Table 4.5. We made a questionnaire for acceptability level of the three-way coconut shell sander. Conclusions. The machine was fabricated to aid the sanding process of coconut shells for calamine productions. This study performed several trials in order to test the performance and functionality of the machine. The following conclusions are derived from the data, interpretation, and analysis of the results. Recommendations. Based on the results, recommendations for improving the performance of the three-way coconut shell sander are encouraged. Further, research is recommended in the following aspects. 1. Future researchers are advised to lessen the diameter size of the disc and the bowl sander because smaller diameter size of coconut shells are used for calamine products. 2. Future researchers are advised to remove the working tables because if the shells hit it, it may be bounced back to the operator and may cause injury according to the respondents.
That's all and thank you.